let's solve this thing. Let's see if we can solve it. Boom, bada bing. Okay, let's draw in our little picture here. So what we have is we have a strange scenario where we've got some weights sitting on a slope. So do that, do this. Okay, put that guy there. Let's have this like obsession with trying to like get these things to sit on here perfectly. Oh, they never quite do. Close enough. Okay, then we got a pulley at the top. Put that in place. There. Okay, draw some other lines on here. Okay, we've got some ropes attached here. This attention to detail. All right, look at that. That's beautiful. Okay. Perfect. Let's make this guy just a little bit taller because he's weird looking. Oops. All right, good enough. Okay, so then we had values for the weights here. We had this at 10 kgs. We had this guy at 2 kgs. We had some angles here. We had 60 degrees here. We had 20 degrees here. And you were also informed that the coefficient of friction in this case was 0.08. All right. And you were asked two things. One, find acceleration of this system. And as a bonus, find FT or tension in the rope. Okay, this is going to take a little while, so strap in. The first thing that we need to do is start to look at what forces we expect to be present here. So before you even start, I would say just lay this out for yourself. You know there's going to be an accelerating force down the plane to the left, and you know there's going to be one over here down the plane to the right. Okay, and we'll get into where those forces are from in a minute. You also know that there's friction involved here, okay? And probably just with your spidey sense, you can see, number one, this is a more angled slope, so the FA will be large here, and this has more mass, so the force of gravity on here will be greater. In other words, this will tend to move to the left, okay? What that means is the friction here will act to the right, and the friction here will also act to the right, okay? And that should be it for forces that are moving this, say left or right. There are other forces like the normal force and so on, but we're using them to find friction, okay? And we'll deal with tension later. So let's look at this guy first and figure out what forces are present over here, okay? So I'm just going to draw a rough sketch to help myself out. We've got this. Oh man, that is really rough. I think I could be a little neater than that. Okay, perfect. So we got 10 here. Extend this page down. We've got 60 degrees here. So we've got this kind of a scenario when we set it all up. Okay, so here's the normal force. Here's your weight. Weight equals mg. Okay, and then we have the resultant force here, which we call Fa. Okay, so let's figure out what Fa would be. If this is theta, okay, then we would have this being equal to the hypotenuse times the sine of this value. Okay, so we would say mg sine of 60 degrees there. Okay, Fn we're not really directly interested in. What we really want is the force of friction, but we know that this would be mg cosine of theta, right? Because it's the adjacent angle. And what we really want here is we want that force of friction on this side. Okay, so that is going to be mu times Fn, or mu mg cos theta. All right, let's collect some numbers here. So mass we said was 10 kgs, G 9.81, sine of 60 degrees, and this will be acting towards the left. So we'll just round that to 85. 85 newtons, and that is to the left. Okay, and then FF. I should really be including my units here, but and mu is times 0.08. Okay, and let's see what we get for that. And you get roughly just rounded 4 newtons for that. Okay, and that's going to be against the motion of this object. Right? Now we're going to do the exact same thing on the other side. So we've got 30 degrees. Okay, we've got this mass. So it's going to have, you know, it was 20 degrees. Oh, sorry. 20 degrees. There we go. Okay, so we've got this, this, and this. So we're going to have FA prime is going to be 2 kgs times G, right, times the sine 20 degrees. And FF here is going to be mu 0.08 times 2 kgs times 9.81 times the cosine of 20 degrees. So we'll solve those. Okay, so solving for this, 6.7 newtons to the right and 1.5 newtons to the right for frictional force. All right, so now what we want to do is we want to find the net force going on here. F net equals. So we have 85 newtons to the left, so we'll maybe start with that. Negative 85 newtons. The negative here just indicating direction. Plus 4 newtons, so frictional force from here. Plus 6.7 newtons. Plus 1.5 newtons. And let's see what we're left with. Okay, so what does this value mean? Well, it means that once we've considered all the friction and all those FA values, okay, that the net or the resultant force is 72.8 newtons to the left. Okay, so if we roll back up and just look at that, acting on this entire system, once all of these forces have been resolved and dealt with, the overall force is 72.8 newtons in that direction. Okay, and we were asked to find acceleration. So acceleration from Newton's second law, we know this is true. Just do a little rearranging. We should get this, 72.8 newtons, negative just meaning to the left, divided by the mass. Well, the mass is 12 kilograms, because you have to include the mass of the entire system. So what do we get? So we go, negative 6.1 meters per second squared. Okay, so here's our initial scenario. We figured out that the overall acceleration on the system is negative 6.1 meters per second squared. And now we're asked, what is the tension in this rope? And the first thing to understand is that the tension in this rope, there's only one tension in this rope, okay? If we were to take a spring scale, if we were to place it in here, okay, it would read some value, you know, whatever that tension happens to be. And it would not matter if we installed it to the left or we installed it to the right, it would still read the same value. Tension is like that. It pulls equally in both directions at the same time, like tug of war, okay? So from the 2 kilograms perspective, tension is acting up and to the left. From the 10 kilograms perspective, it's acting up and to the right. In order to solve for tension, we simply look at 1/2 of this scenario, okay? So let's split it in half down the middle. Let's only deal with this side, okay? So let's figure out what's going on here. All right, so what do we have going on? We have a rope that has some tension in it. We have a 2 kilogram block, Okay. We have our slope that it's sitting on at 20 degrees. Okay. And we also know that there is an acceleration here, right? And we know this is 2 kilograms. And we know that this acceleration is 6 point, what was it again? 1 meters per second squared. Okay, so what that is essentially saying then is that there is some overall net force on this object, okay? And what is that net force made up of? Well, it's made up of Ft plus Fa plus Ff. Okay, why is that true? We have this force acting to the left. We have our weight here. We have our normal force here. We have our Fa force here. That's theta. Okay, so that's Fa. That acts to the down and to the right. And last but not least, there's a frictional force over here. F. And we also know something else, don't we? That F net is equal to M times A, right? So once we figure out all these forces and how they all add up together, the result of them is that they cause an acceleration in that direction. Okay? So let's just make sure that our arrows and our negatives and positives all work out correctly, and let's see what we can sort out here. So what we are after is this guy right here. Okay? So we could say then MA equals Ft plus Fa plus Ff. Okay. And we want this, so then we could rearrange to say Ft should be equal to Ma minus Fa minus Ff. All right, so let's see if we can't get this to chooch here. So Ma, all right, so we got 2 kilograms there. And we know it's accelerating at negative 6.8. No, not 6.8, 6.1. Right? Minus Fa, which is mg sine 20 degrees minus mg cosine cosine 20 degrees. And what do we get? Brain not working, brain back to working. Okay, we're good. What happened to you? I'm gonna run out of room here. All right, let's put some numbers in and see what we get. So we've seen some of these values before. If you have them at hand, you can just go ahead and use them right away. Okay? So what we're saying here is this leftward pull has to be large enough that it can counteract Fa, right? This is a Fa down the plane, and counteract Ff, right? And still have enough force to provide an acceleration on this mass of 2 kilograms leftward at 6.1 meters per second squared. So you should expect this number to be larger than, 12.2, right? It should be the sum of all these values. Let's see what we get. I get that tension has to be negative 20.4 newtons. Okay? So I just want to make sure we can go back up here and make sense of all this. So what we're saying here is that you have an Fa here, You know, since it's moving to the left, that you have an FF here. You also know that you have an acceleration of 6.1. So you have an F net equals ma here, right? Or you have an acceleration on this object, so you have, a force equals ma. So what you're saying here is that this force of tension is large enough such that it counteracts Fa, it counteracts Ff, and it's large enough that it also produces an acceleration of 6.1 meters per second on this 2 kilogram object. That's what we're saying about this force of tension. Okay? If we look over here, okay, without any tension at all, if we cut this rope, the acceleration of this object would be larger than 6.1. The force of tension acting this way essentially works to decrease the amount of acceleration that you would normally have over on this side. Okay? You could have done the math on this side just as well, and you would still get the tension equal to this amount. Okay? So 20.4 newtons over to the left. However, on the other side, would this value be positive or negative? It would be positive because from the perspective of the 10 kilograms, it's pointing to the right. Okay? So as a challenge, before we leave this, I'm not going to do video on this, but as a challenge, can you guys prove Ft equals 20.4 newtons from the perspective of the other weight? That's your bonus homework.